Hi, I'm Ian Wong from Square. Square is making commerce easy for everyone. We are helping businesses accept credit cards, grow sales, and offer their customers a fun and simple experience at the counter, all with a free app and card reader. In this guest lecture, I'll cover 4 rules that are distilled from working with other engineers at Square. And hopefully when you apply these 4 rules, you will be able to create an effective startup engineering team. So let's begin. Let's first begin by getting onto the same page with the term effective. What do we mean by that? The definition we'll use is very straightforward. An effective startup engineering team ships useful and delightful products to the customers at a fast pace. So in this presentation, I'll cover 4 rules that when applied will hopefully help you build this effective startup engineering team. And where am I distilling these 4 rules from? Over the last 2 years, I've had the great pleasure of working in an effective startup called Square. So let me first take a moment now to introduce to you Square. Our mission at Square is very simple, and that is to make commerce easy for everyone. We began 4 years ago with a very simple premise, and that is to enable anyone to accept credit card payments anytime, anywhere. And since then, we developed the Square card reader and the software into a full-fledged point-of-sale system known as the Square Register. Square Register not only enables merchants to accept credit cards, but also to share location and menu information, among other things. Merchants can even log on to squareup.com to see their sale history and understand better how their business is doing. With the Square Register, Square firmly planted itself onto the counter. But we didn't stop at the counter. We looked across the counter and we realized that, hey, we should simplify the buying experience for the merchant's customers. So as a result, we built Square Wallet. Square Wallet is a fast and easy way to pay, not only at your favorite businesses, but it also allows you to discover new businesses and create loyalty programs with these merchants. And because we've been very effective at shipping products such as Square Register and Square Wallet, we've gathered quite a bit of momentum behind us. We're currently processing more than $10 billion in payments annually. And last year alone, we grew our customer base from 1 million to 3 million. There are currently more than 250,000 businesses listed in the Square directory. That's a lot of businesses. And our readers are available in nearly 40,000 retail locations nationwide, from Best Buy to Apple Store. Fun fact, if you were to take our transaction volume, add it all up, that will make us the equivalent of the 20th largest retailer in the United States. And so hopefully I've convinced you that Square is effective as a startup and that the 4 rules might be applicable to you. And before I dive into these 4 rules, let me take a moment to first introduce myself. My name is Ian. I'm an inference scientist on the RISC team. Inference scientist is just another word for data scientist. Prior to Square, I dropped out of a PhD program at Stanford. I've got way too many degrees from Stanford. Day to day, I work on the machine learning systems to assess and mitigate the risk of various entities and events in our network. And prior to that, I focused primarily on visualization and workflow tools for our ops team to review customer accounts. So without further ado, let's talk about the 4 points that I'll present. And they are in order of presentation: design for modularity, learn to test, use and contribute to open source, and foster an open, collaborative, and responsible culture. And let's begin with design for modularity. I guess to begin, what does modularity even mean? So we say that a piece of software exhibits good modularity if it's comprised of components that are well separated and where each component does one thing and one thing only very well, and where these components interact with each other via simple interfaces. Modularity really is a proxy for simplicity. When a piece of software exhibits high modularity, chances are that it's very simple. And so why should we strive for simplicity? Well, a very smart man by the name of Rich Hickey, who's the author of Closure, had this excellent presentation called Simple Made Easy. And in this presentation, he made the argument for why we should strive for simplicity. His argument goes like this: we can only hope to make reliable those things we understand, and we can only consider a few things at a time. Intertwined things must be considered together, and as a result, complexity undermines understanding. In other words, to even build things that will be reliable and that you want to change and add on over time, you really have to make them simple from the beginning. In other words, to put it more bluntly, you want to avoid things like this. So I did my undergrad in electrical engineering, and this is a very typical example of the circuit board I would build. It's a mess. And basically, it's very hard to swap pieces in and out. You're pretty much doomed to start from the beginning if you have to change a piece out. It makes for very entertaining movies like Inception, where the plots are so intertwined and complex, but it's pretty bad software engineering practice. And I bet that if I were to look at the code submissions from this class, I'll find some of this. And maybe you'll find that you're encountering this entangled mess in your code as we speak. And those things are usually found in something what we call as a God class. So here's a sublime text preview pane of one of the classes I had to deal with, which is self-contained over 1,000 lines of code, which is itself kind of a code smell. And you know that you've encountered a God class when it tries to do everything, right? When it's harder and harder to add functionality. And when things feel tangled, meaning you try to add method A, but somehow that affects method B, right? And then there are lots of states and side effects in this class. It's kind of like trying to put two magnets together with the same poles pointing at each other. It just doesn't feel right. And it just feels harder and harder to just modify functionality. And if you're suffering from these maladies, here's a simple remedy that you might want to try out. And this technique I refer to as extracting a service class. Here are two resources, one from Sleep Klatnik, the other one from Gary Barnhart at Destroy All Software, that describes this method. They call it extracting domain models, but the technique's the same. And the technique basically refers to stop adding functionality to your model or controller. So in Ruby on Rails, typically you find very bloated user class or various controllers that does a lot of logic. Stop adding functionality to these things. Extract and create a service class instead, right? And let me illustrate this with an example with some code I wrote at Square. So here's a refunds controller that we have at Square. What this does is every now and then merchants will submit a refund request. And every now and then we have to manually approve or reject these refund requests. So in this example, we have an approve method in the refunds controller class that does not only verification that the logged in user is a Square employee and it may approve refund, but also the actual logic for approving that refund. And finally, when it gets the response from whether or not the refund was completed, it then sends a message back to the logged in user to indicate that the refund was either completed or failed. So this class is actually trying to do a lot of different things, and I found it very difficult to modify this code. Moreover, it's very hard to reuse the logic. So what I did was I actually removed a lot of the core logic around under what circumstances we can approve a refund, and extract it into a service class known as risk refund processor. I have a namespace under risk to indicate that, hey, it's the responsibility of risk to do approvals for refunds. So I think that what you'll find is, as you're extracting these service classes, you're paving yourself a nice road towards a service-oriented architecture that will enable you to scale. And why is that? Well, actually, there's very little, if any, conceptual differences between a highly modular code base and service-oriented architecture. Why? Well, if you have a highly modular code base, then that code base consists of loosely coupled, well-encapsulated service classes that interact with each other via simple interfaces. And to extend that in a macro scale to a service-oriented architecture, an SOA just consists of loosely coupled, well-encapsulated services, right, that interact with each other via simple interfaces, right? So all we did was just find and replace the word service classes with services. And conceptually, that's the main difference between highly modular code base and SOA is just the scale of which you're operating. To illustrate why striving for modularity is so important at a macro scale and an SOA scale, let me talk about life of payment at Square. So suppose you take a payment using our card reader connected to your iOS or Android device. That payment information goes to our payment processing services. This is the set of services that figures out what card this is, which payment gateway the payment processing should be delegated to, whether or not there are funds for authorization and capture, and it basically takes and it sends a response code back to the client after it successfully completed the authorization and capture, or actually upon the decline of such as authorization. So now that this payment processing services has taken a look at the payment, that payment information is then actually sent to the systems that I work on risk assessment. Is this payment suspicious? Does this payment lead us to high exposure? And for those payments that might have risky chargebacks associated with them, we will enqueue them for manual review. But for the majority of payments, we clear them for settlement. And then we tell the settlement services, which are very, very nuanced and complex in their own ways, to settle these payments via the ACH credit system, which will then create payouts to our merchants' bank accounts. And the point here is that an individual service can grow in complexity without being concerned with other services. Payment processing is a very interesting and challenging piece of software to write, primarily because of reliability concerns. Payment processing needs to be up all the time. On the other hand, settlement is very difficult because we need to calculate to the penny what we need to pay out or withdraw from our merchants' bank accounts. And payout schedules is more difficult than you might think. And in terms of risk, here's just some examples of the code bases that we have in risk. We have code bases like ModelKit in the bottom that is actually doing the machine learning model training, the signal service that is computing the real-time risk signals. We have things like Gandalf, kind of you shall not pass, right? So Gandalf is our orchestrator that takes in a new payment, sends it to Risk Arbiter, which takes the output from signal service and ModelKit and tells Gandalf, hey, this payment is risky or not risky. Gandalf then takes all the risky payments and enqueue cases for manual review in Regulator. And for the payments that are clear, that have low risk, Gandalf then clears them for settlement by communicating with our settlement services. So you can see that we are able to achieve separation of concern from within the risk assessment system to payment processing and settlement because we have the service-oriented architecture. And the SOA essentially enables us to scale without being too concerned with coupling with other services. And to conclude this section, I'd like to bring up this graphic from Simple Made Easy by Rich Hickey. And in this graphic, it depicts iteration speed or development speed over time if you choose to go with the easy route versus a simple route. So going with the easy route is something akin to just adding on to your God class, right? It's simple. It's easy to keep adding on to your God class. But what you find is that over time, your development speed is greatly hampered because it's very tangled and it's very, very difficult to add features. Whereas if you take the simple route, what you'll find is that, yes, you do take a hit initially. You have to be very thoughtful about how to structure things. But over time, you actually pick up some momentum and development speed and are able to scale to solutions, much larger solutions for specific problems. And that's the route that we've taken at Square, and it's helped us out a lot. And to be frank, a lot of times in school, or maybe even in this course, you'll take the easy route because your time horizon is only a quarter or what have you. But really, I would encourage you to think about the lifetime value of your code base, right? You want to be able to be effective and ship high quality products to your customer at a constant high rate over time. So try to increase your time horizon from 1 quarter to maybe 2 or 3 and hopefully more. And try to take the simple route. It's not going to be easy, but it's going to be very worthwhile. And with that, I'd like to move on to the second segment, learning to test. So testing is one of these things that they don't usually teach very well in school. In fact, I had no idea what the different types of tests were while I was in school. So why should one learn how to test? Gary Barnhart, who's the author of Destroy All Software Screencasts, had a great talk at the PyCon called Fast Test, Slow Test, in which he outlines the 3 goals of testing. So here are the 3 goals. Number 1, learning tests prevent regression. Number 2, they prevent fear. And number 3, they prevent bad design. So let me go over each of these reasons in a bit more detail. So the level 1 awareness of why one should learn to test is that they prevent regression. What that means is you're able to introduce change that would not unexpectedly break what you already have. When you have run a test and you see these beautiful green dots, in this example I have 66 examples, and they're all passing, I know that, hey, I haven't broken anything anyone else has done before. right? You know that every single decision that has been made has been tested, and that you should be able to add new features without being worried about the past. Because the last thing you want to do is that if you don't test your code, your customers will, and you don't want your customers to be your first line of defense for your crappy code. This tip is stolen straight from Pragmatic Programmer, which is a great read, highly recommended if you're to take software engineering seriously. So this is what I would refer to as level 1 awareness of why one should learn to test. Level 2 awareness is that testing prevents fear. Not just the fear of, hey, I'm adding something new, is it going to break anything else? But really, as the code base becomes non-trivial, as you have multiple contributors to the same code base, you will find yourself constantly needing to refactor things or change things up, add functionality, modify functionality, simplify things. And without a test, you really can't refactor with confidence. And it's very important to be confident in changing functionality. For instance, in the admin controller, I knew I needed to to disentangle the mess that was the controller. I will need to disentangle the verification of the logged in user from the actual refund logic from the response message. And so I knew I could extract things at will because I have a test for my controller. And so long as the controller test passes, I know that I'm in the clear. So here's what it looks like. And in fact, because I was able to extract so easily, I was able to write a unit test that covers the refund processor class much more tightly. And what's really nice about that is that this test actually serves as documentation and contract for the refund processor class. In fact, many times when I develop at Square, I don't really have to refer to documentation or the implementation of a class. I would sometimes first look at the test, because the test for the class should indicate exactly what the class should do, nothing more, and certainly nothing less. And so that's kind of the level 2 awareness of why one should learn to test. The level 3 awareness, kind of, when Neo stopping the Sentinels, is that testing encourages good design. That being a class that is testable is often loosely coupled from other classes, and that has a very well-defined interface, and that it only does one thing well. So concretely, how can you use testing to drive design? Well, here's one way that is espoused by Growing Object-Oriented Software Guided by Tests, which is another great book if you're to take software engineering seriously. It's highly recommended. So in the book, it talks about this methodology of first writing a failing acceptance test. So for now, think of an acceptance test as just a big test, an end-to-end test. So you write this big failing test, and then you start writing a smaller failing unit test. And the unit test, just consider that for a moment as being a small test, right? So write big failing test, write smaller failing tests, make these smaller failing tests pass, refactor if necessary, and use that inner loop to drive out smaller components that will eventually help you complete or make the larger acceptance test pass. And what you'll find is that when you do this inner loop and outer loop, you will come up with a design that's decent because testing forces you to design things well. I'll illustrate that in a moment with some live coding. And before I get there, I just like to clarify what I mean by acceptance tests versus unit tests versus something we call integration tests. This is stolen from Misko, who's a Googler, and he's given a great series of clean code talks. I encourage you to YouTube online. So just to go over the different types of tests, we begin at the top of this pyramid with things that take a long time to run, known as acceptance tests. So acceptance tests test the whole application. For instance, you have to spin up your web app and see if a certain button appears. Or if you do click on a certain button, whether or not some side effects much further down the logic chain is activated. In this example, you mostly just want to test whether or not the happy paths to your code base is activated and is correct. You don't have, because the runtime is so slow, you can't really run all the possible variations of the logic in your code base. On the other extreme are unit tests. A unit test focuses on a very particular piece of application logic. It gives you very quick feedback. It usually runs very quickly, and that's where you want to spend the majority of your time, or at least crank out the majority of your tests. Right, so this pyramid actually indicates the number of tests that should exist in your code base, at least for web apps. And finally, in the middle, we have integration tests, which is somewhere in between acceptance and unit. Oftentimes, as much as we'd like to write only unit tests, sometimes it's actually very hard to simulate the external dependencies, or rather to mock up the external dependencies for a given class. So in those cases, you actually have to simulate these external dependencies. And the integration tests test not just the class, one specific class, but also the collection of class that this class under test might collaborate with. So let me stop talking for now and actually show you how this is done. So what we'll do is we'll test drive Gandalf. And just to remind ourselves, Gandalf is this code base we have in Risk that orchestrates the reviewing of payments and a queuing of manual review cases. So the responsibility of Gandalf is to take payments, ask for arbiter if the payments of high risk, and for those payments with high risk, Gandalf will then enqueue them for manual review in Regulator. So let's get straight to it. Let's test drive Gandalf. So I have a directory called Gandalf TDD, short for test-driven development. That's very bare bones right now. It doesn't really have much. I will be coding in Ruby, and I'll be using Vim as my text editor. So let's begin by actually writing the spec or the test for Gandalf. And I'm actually going to start by describing what Gandalf should do. Gandalf should create case for manual review in Regulator for merchants with high risk payments. So this is the responsibility of Gandalf. It's very important as you are doing test-driven development to be able to run a test quickly. So what I'm going to do here is I'm going to map my leader arm Vim to run the test. So I'm going to run it. It's going to complain that it doesn't know about Gandalf. What is this constant Gandalf that you're talking about? Well, for the purpose of this demonstration, I'm just going to write the implementation in the same files as the spec. Great, so now I have a pending test. Let's start filling this test in. One tip is as you do more and more testing is actually to write the assertions first. In this case, I know that I need a hook into Regulator, and so I will need some concept of a Regulator client, and that it should receive some method, probably called create case, crease case, and it should receive it with, say, the merchant ID corresponding to, say, a bad payment, sorry. Clean this up a little bit. Great. So this is the assertion. At the end of the day, Regulator client should receive create case with the merchant ID corresponding to a bad payment. So with that, let's actually create a bad payments. Let's just say it's one that has ID 1, some merchant ID, and it's not reviewed yet. Similarly, good payments, we'll just have ID 2 and some separate merchant ID. And let's run Gandalf. And probably the signature on the method I care about, let's just call it review payments. And here, let's give it good payments and bad payments, because that's what Gandalf does, it reviews payments. And here, what I've done is that I know that I will need I'll need to eventually create case on Regulator client with a method that will, with the data merchant ID corresponding to the merchant ID of the bad payment. I don't actually care for the purpose of the test how Regulator clients instantiate it. So generally, for kind of things in your tests that are substitutions for production code, we can use the concept of a test double. Now there are many different types of test doubles, and this one is actually this one is definitely a mock, where we're asserting that the test double should receive a method call with certain parameters But generally, there are other types of test doubles like stubs, like spies. But I don't have time to cover all of those, but I encourage you to look it up. So like I mentioned, I'm not really interested in how regular clients instantiate it. All I care about is that it's something that receives this call. So how is Gandalf going to be aware of regular client? One common technique that I find very clear is to inject the dependency through the constructor. So now this is very explicit that hey, Gandalf, an instance of Gandalf depends on an instance of a regular client, and that's how the two classes will interact with each other. So now when I run the tests, it's going to complain that hey, the constructor doesn't know about this regular client business. So let's put that in the constructor. Great. So now I have injected this in the constructor. And when I run the test again, notice how I'm constantly going from the test to the implementation. That's kind of the cycle that you should, hopefully you'll find yourself doing. Now it doesn't know about this method called review payments. So let's add that in. And what this method does is that it loops through each payment, and it will create a case in regulator. Great, so now when I run the test again, it's going to complain correctly, since I have a bug, that it got the merchant ID corresponding to a good payment as well. So as you can see, so far I have not excluded good payments from being enqueued. So this would be a massive waste of our ops team's resources. We want to just enqueue the case for manual review if it's potentially suspicious. So let's say that if the risk score, we should enqueue only if the risk score of the payment is beyond some cutoff. And for purposes of demonstration, let's just put the off to be, say, some arbitrary numeric value 2. And how does it know how to score? Well, remember risk arbiter? Turns out we'll probably need it here. So again, I don't care about how risk arbiter is instantiated, but whatever it does, it should receive the score method with a payment ID that corresponds to both the good payments. And for the purpose of the good payment, let's have it return a low risk score. And we should also receive a bad payment, in which case, let's just say it receives a high risk score. And how is Gandalf going to know about risk arbiter? Well, let's again inject it in the constructor. So let's do this thing again. And what I'm going to do is say scoring a payment. It's just submitting it to risk arbiter ID. So now when I run the tests, the test passes. And so I think what you'll find is that this way of writing a test first and having it guide the design of your classes will actually help you discover the proper interfaces, right? So I figured out, hey, we should probably call that review payments on the method on Gandalf. And then the method on the risk arbiter client should probably be called score. And the regulated client, we know is kind of obvious that the method there should be called create case. But because I'm writing the use case first through this test, it actually forces me to think about my collaborative classes and interfaces on them. And it forces me to be very explicit about my dependencies in Gandalf. And with that, I want to stop this live coding segment and move back to the presentation. Returning to the presentation, let's now talk about the third point, which is to use and contribute to open source. Another way to put this is to develop an open source philosophy. At Square, we rely and we're built upon open source. anywhere from Postgres and MySQL on the database side to Guava and Juice on Java to Ruby on Rails, the framework. We rely on very well built software built by experts. And in fact, many of our developers are active contributors to open source software. And I hope that many in the audience are or will become open source developers, or at least contributors. And the thing with the value add for the startup isn't necessarily to build open source software, it's to leverage as much as you can and build exactly just what you need to deliver value. But sometimes you'll find that you'll need to invent. And when you do need to invent, you should try to the extent possible open source that work. Now, no one's asking you to open source your secret sauce. In fact, for us, in Risk, we'll never open source our Risk features and our Risk algorithms, but we'll probably, when it's more mature, open source the way we build models, the model building pipeline, because we think that's lacking in the ecosystem. And in the process, hopefully, we'll build our brand around machine learning development. Similarly, as you open source different parts of your stack, you're really making a statement about your engineering team and your engineering brand. So at Square, we have many open source projects. Here are just 5 from github.com/square. So the first one, as I mentioned, we test heavily at Square, and that extends that goes not only from the server side, but all the way to the client side. So we have KIF, Qubit Functional, as an Objective-C, and is an iOS functional testing framework. We also have Kane in Ruby that does code quality threshold checking. We have Dagger in Java for dependency injection, which is a term I used earlier in the TDD segment. We have Cubism, which I'll go over in more detail in a second. And we have Squash, which is a cross-platform library for exception tracking and bug reporting. So I want to spend a quick moment to talk a bit more about Cubism. So Cubism allows you to do time series visualization through horizon charts. So let's actually jump to an example here. So here's an example of the relative performance of stock price as compared to December 2008. So here you'll find that Apple, for instance, has been on a great climb from September to April, right, where the stock price increased almost by 100% sometime in April. And what's interesting about the horizon charts is that it uses both position and color to compress the y-axis. So here, the green, which indicates positive change, relative change, actually loops around above the top x-axis back to the lower x-axis. And now we can show relative change on the order of plus 200%, right? And it gets even darker when the third time it loops over, and even darker the fourth time it loops over. Conversely, you can also see negative changes. For instance, here you can see both Microsoft and Adobe having some difficulties with their stock price, and they were able to rebound afterwards. Well, you see that here there's a blue segment that indicates negative change, and again here you'll see that there's a large negative change, which is indicated by a darker blue, because that blue is kind of looped over the bottom x-axis and started from the top. And Balaji kind of asked me how would you actually get started with Cubism or D3 visualization in general. One of the greatest tools you can have is actually to reach into your developer console in Chrome or your browser of choice, and literally just open up the script tag, and there you have it. Here's the actual code, right? So it's actually very easy to copy and paste, spin up a simple HTTP server in Python, and you're ready to play with D3 and Cubism. And in this example, all you need to do is just lay out a bunch of empty divs, put this code into a script tag, and you should be able to reproduce this visualization easily. Returning to the presentation, why do I want to kind of bring up Cubism? Well, here's an example of how we use Cubism at Square. We use it a lot to do server monitoring and service monitoring. In this example, we are displaying the horizon charts for some of our API servers, and in particular the load averages of our API servers. As well, I'm also showing our monitoring on service latency for a particular service. You notice that these plots are very boring, and that's actually a good thing for us. We generally like load to be very low and consistent, and service latency to be also very low and consistent. But when things do happen, Cubism is a great tool because it allows us to see so many things together. We get to see coincidental anomaly. We get to see the unexpected. By placing all these horizon charts together, we can see, for instance, hey, maybe the database is a problem, which is why we have the sudden spike in service latency. And these are things that might be otherwise kind of hard to put together. And with that, I want to conclude this segment and talk about my last point, which is to foster an open and collaborative, responsible culture. The fourth rule in creating an effective startup engineering team is to foster an open, collaborative, and responsible culture. One of the basic ingredients of creating an effective team is not only to have talented engineers, but also to have motivated and engaged engineers. So how do you encourage that? Well, one way is to begin with an open culture. At Square, we try to foster an open culture by first creating transparency. So here is a picture of our office. You'd first notice that it's very open. And the second thing that you might notice, are these monitors that are mounted from the ceiling. We call them information radiators because they're constantly radiating information that are very relevant that should be shared across the entire company. Information such as the gross payment volume for a given day or the active merchants that we have on our system. It's very important for everyone to be aware of these metrics so that we are on the same page with respect to where we're at and where we need to head to. We also have the practice of compiling meeting notes and setting it to Notes At. Notes At is an email alias that all employees are subscribed to from day one, which is to say from day one, you have access to all the meetings that have happened in the past, and we continue to have access to meeting notes in the future. And something really interesting happens when you have this level of radical transparency, and that is that it leads to engagement. I'm not a psychologist, so I can't really explain this very well, but when I'm aware of a piece of news, a decision that was made in a meeting, or a new project that's spinning up, I'm naturally very engaged. I'm very curious to see to its success, which actually leads to a sense of responsibility. Since we're all on the same team, I want that project to succeed. I want to be held accountable for its success, and I want to enjoy the success with you, my teammates. So transparency leads to engagement, which leads to responsibility. So if you want to have responsible engineers, one way is to foster an open culture. And fun fact, most of the conference rooms at Square has a glass wall like this one. So if you take a stroll around our office, you're actually able to see most of the meetings that are going on, which is actually which speaks to the transparency that we have in the office. A very effective way of creating a collaborative engineering culture is to pair program. Now, I'm not going to explain how to do it effectively. For that, I'll defer you to excellent answers on Quora, because this could be a talk in and of itself. But just to enumerate some of the benefits of pair programming, let's start with instant code and design feedback. In pair programming, typically you have a driver and an observer. And the observer's role is to give feedback to the driver. Hey, you're writing this test really well. Hey, did you consider this design? Maybe we should write this extra test. So the idea is that there's a constant feedback loop even within the same terminal, which is great. Another benefit of pair programming is that it allows you to learn from one another very quickly. I've learned so much from my partners in pair programming, anything from tips in using Bash to editor tricks, all the way to testing philosophy and design choices that we make in various production code. The third benefit of pair programming is that it's the fastest way to onboard new hires. One way of onboarding new hires is to just stick them into a room and ask them to write documentation. But I think what you find is that when you have a new feature, why don't you actually invite this new hire to pair program with you? It might be a bit painful as an experienced person for a little while, but you'll soon realize that you're actually giving the new hire a big benefit, and giving yourself a big benefit by helping them become as productive as possible in a short amount of time. And when I do pair programming well, usually I'm exhausted by 5 p.m. That's because I had no excuse to check Twitter. I'm constantly engaged in coding. I'm constantly talking about design with my partner in pair programming. And perhaps the most important point is that pairing on a problem becomes part of the common parlance. I think because Square espoused pair programming early in its life, pairing on prom really it's a great thing to have as part of your culture. Whenever I'm stuck or one of my fellow engineers is stuck, we always kind of just approach each other and say, hey, do you want to pair on that? And that's a very, very powerful concept to have in your company. Finally, how do you foster a responsible culture? One way is to entrench these in engineering processes. At Square, we have a lot of engineering processes that help us do that. And these processes are discussed in much greater detail by one of my colleagues, Erica, at her talk called Failing Fast, Stuff We Should Have Done Better at Square. And I'll just summarize some of these processes here, beginning with code reviews. So at Square, we move people's money, and that's serious business. And so we treat our code with great rigor. And we also view ourselves as craftsmen of code. So because of this, every single piece of code that is checked into master, that's merged to master, must have at least 2 pairs of eyes who've seen it before. Another process is the on-call rotation. Every single service at Square has someone who's on call, someone who is available to react to any sudden exceptions or service unavailability. We also schedule postmortems for when things do happen, when the unexpected or the unfortunate happens. We need to make sure that when failures do happen, we recognize the failure and we learn from the failure so we don't repeat them again. Finally, we have retrospectives every 2 weeks. So every 2 weeks, sub-teams within Square will gather, and it's kind of an interesting process. We all go into a room, and we would, on the whiteboard, draw a happy face, a meh face, and a sad face, along with action items. And then we'll proceed to enumerate all the things that have gone well in the last 2 weeks, so-so, not so well. And from that list, we distill action items, and we're very good about following up with our action items. And the idea behind all this is to make sure that we're constantly performing efficiently as a team. And as such, that we are responsible for the efficiency and maintaining that efficiency going forward. And so this concludes the last point on fostering an open, collaborative, and responsible culture. And just to recap, here are the 4 points that I mentioned in my talk. And I know that a lecture is cheap. You might not learn anything from this lecture. And I know that when I was a student, a lot of times words come in through one ear and out goes the other. So I'd encourage you to all just do something very simple later today. If you can take nothing else from this lecture, just do these 3 things for me. The first thing you should do is extract a service class. Look at the part of your code base that you're feeling the most pain in terms of adding functionality. Chances are things are very tangled. Do yourself a favor and extract a service class. Second, write a test next time before you implement. Stop writing the implementation right away. Make sure you have a test and that verifies at the very least that your implementation will work. And you have no tests in your code base so far, well, now's a great time to start writing the first test. And finally, pair programming with your teammate. I think you'll find this process to be very rewarding over time. So I've covered quite a bit of material in this guest lecture. And don't worry if you didn't catch everything, because Square is hiring. And the fourth thing that you should do today is to check out jobs.squareup.com. If you enjoy startup engineering and you've enjoyed my talk, please visit this website. And this concludes my talk. So I hope you enjoyed the guest lecture, and I really hope that you will do the 3 things I asked of you at the very end, which is number 1, extract a service class, number 2, write a test before you implement, and number 3, pair program with your teammates. And hopefully by following those 4 rules, you will be able to create an effective startup engineering team. And with that, good luck with your course, good luck with your projects, and thank you for listening.